Hey there, and welcome back to the video series. So we talked about BubbleSort in the previous video, and the next one here is SelectionSort, and it's based on the same two loops, but it is faster than BubbleSort. It is still what we call a quadratic algorithm, so we have this big O of n raised to the power of 2, so if we double the list of items in our array, we will multiply the execution time or the runtime by 4. So it's the same, it is in the same time complexity class as BubbleSort. But yeah, we have the code here, but let's go and take a look at how this algorithm works, because if we start the algorithm here, SelectionSort, we can see that the idea behind the algorithm is that it will search for the largest element, and then it will place that element in the end of the array. So we can see that now it will swap it with the last element there, and then it will do the same procedure again with the rest of the unsorted array. So it will always look for the largest element and select that and swap it for the last element in the unsorted array. And if we speed up, we can see that it should be a little bit faster than BubbleSort, because it doesn't have the same amount of swaps as BubbleSort has. So we can also see this in the performance of the algorithm. All right, if we take a look at this comparison between all of the algorithm, we can see that SelectionSort and BubbleSort, it actually indicates that SelectionSort is slower on this illustration here, because we can see that BubbleSort finishes first. So I don't know how that works here, but we're going to do our own benchmark to see which one is the fastest. Right. So how can we implement this algorithm? Well, if we go back to our framework, let's make a new class here. Let's make a new Java class called SelectionSort. Still in the same time complexity class as BubbleSort, but let's see. So we're going to extend generic algorithm. I have it right here. And IntelliJ is angry with me because I haven't implemented the do work. So we're going to do that. So now we have the do work here, and we also need a constructor. I think that is what it's telling me here. There's no default constructor. So we do alt insert and provide a constructor. And let's just remove this default here. Let's provide the name SelectionSort, and we provide description. Symbol big O n of 2. Whoop. If I can type here. Sorting algorithm, and it is sorting algorithm. So now we can display this in our framework. And let's just implement the method here. We have the code right here. So we take the code in our, let's just minimize the output there, and we have the B array again. So we're just going to create an array of integers called B, and we also need to typecast this here. We call our superclass that has all the test data that was generated for us using the framework, and then we can sort it. Okay, so that's pretty much it. We go to our algorithm loader, and we have only BubbleSort. Let's add SelectionSort now. Whoop. Okay, so that is it here. Let's fire up the framework and let's do some benchmarking. So now we can see that the framework is starting, and we have BubbleSort. We also have SelectionSort, and if we start SelectionSort here, we can see that, let's just start it going to sort it now. We are at 3 seconds. So okay, so already now we are a bit faster. Yes, if we just compare this 128,000 elements, almost 9 seconds for selection sort. If we go with BubbleSort, let's see what happens now. If we have a couple of weird results there, but 7:24. You can see already now it is 8 for half the size. So BubbleSort takes the same amount of time to sort just a half of what SelectionSort did. So this will be around 13 seconds now before it has completed this array here. Yes, you can see around 80 or around yeah, so we can see around 31 seconds to complete, and SelectionSort did it in 8 seconds. So it is faster. Okay, SelectionSort is faster. So that is pretty much it about the SelectionSort. It is also a basic, simple n raised to the power of 2 sorting algorithm. Right. So next up, last video is the insertion sort, and this is the fastest one of the simple sorting algorithms. So let's implement it and benchmark it in the next video.